Hello Year 3 and welcome to today's maths lesson. We are carrying on learning about fabulous fractions. Here is your do now. I suggest you pause the video now to complete, and then when you're ready to carry on, press play and you can check your answers. Here are the answers from the do now for today. Remember, if you're multiplying by 0, you are always going to have an answer of 0, because if there's nothing in your groups to multiply by, you're not going to have anything in your answers. And I also did a cheeky commutativity one. Remember, 3 groups of 8 is exactly the same as 8 groups of 3. So, carrying on with fractions, we are going to be looking at carrying on with our learning from yesterday. So here are our key words. Whole. Remember, my turn, your turn. Whole. Part. Fraction. Numerator. Vinculum. Denominator. Excellent. So we're just going to quickly recap from yesterday. So Percy is back. Now, you may remember yesterday we went through fractions using chocolate biscuits. We don't have any chocolate biscuits to use today, do we, Percy? Percy decided to eat all the chocolate biscuits last night during a midnight feast. So we're going to instead use kiwi fruit, which are an excellent source of vitamin C. Other fruits can be used instead. So I have 2 kiwi fruits here. 1, 2. I am going to split my kiwi fruits into 2 groups. Percy is one of my groups. I am the other group. Kiwi fruit for Percy, kiwi fruit for me. We each get 1 each. We get 1 kiwi for Percy, 1 kiwi for me. But I'm going to take away a kiwi. We've only got 1 left in the fruit bowl, Percy. What would happen then? What would happen then? We would then divide them equally. Divide them equally. So we would split our 1 kiwi fruit into 2 equal parts. So our whole becomes split into 2 equal parts. 1/2 for Percy, 1/2 for me. This is a half. And remember, as a fraction, we write it. A whole is in 2 parts, 1, 2, and each of us get 1 part. So just remember, that is how we create our unit fractions. So, the features of a fraction. The features of a fraction. A fraction is made up of 2 different parts. The top part, we call it our numerator. The numerator is linked, shows us the number of parts we have. It shows us the number of parts we have. The denominator is the number of equal parts in total, so our whole. We then have this word vinculum. My turn, your turn? Vinculum. This is just a fancy word, a mathematical word for the line that separates the numerator and the denominator. So looking at this example here, the number of parts in total is 1, 2, 3, 4, 5. So we have the number of equal parts in total is 5. That is our denominator. Then the total number of shaded parts, so which is in this case the number of parts we have is 1, which means our numerator is 1. 1 part of 5 parts of this pentagon is shaded. 1/5 of the pentagon is shaded? Let's have a look at, see how this would work as well. If we look at our kiwi fruit again. So this is our whole kiwi fruit, which is divided into two parts. 1, 2. So our whole, the number of parts in our whole is 2. 1, 2. I'm going to take away a part. Percy will be eating 1 part of the kiwi, 1/2. We can look at this not just in kiwis. There we go, Percy, enjoy your snack. No, you cannot have a biscuit. We can not just do this using the kiwi fruit, we can use our cubes. I here have a set of cubes. How many cubes do I have altogether? 1, 2, 3, 4, 5, 6. So my whole is made of 6 parts. So my denominator is going to be 6. Question I'm going to ask you is, have a look. I want to know how many of the cubes are green? How many of the cubes are green here? Thinking. 1 of the cubes is green. So if we are going to write that as a fraction, 1 out of 6 cubes is green. So remember, the numerator is the part we have. 1 out of the cubes, 1 out of 6 cubes is green. 1/6 of the cubed are green. But there is often some confusion that I see. Thinking, look at this picture and this shape. Something's not quite right here. There are 5 equal parts. This picture represents 4/5. 4/5. What do you think has gone wrong? Might want to pause and have a little bit more of a think. Look back at, rewind a bit. What's gone wrong? So, how many equal parts do we have here? 1, 2, 3, 4, 5. We know that, but it's always good to check. So, we have 5 equal parts. So remember, the total number of equal parts is our denominator, which is 5. How many parts have been shaded? How many parts do we have? How many parts have been shaded? 1. We have 1 part. What do we think that's gone wrong with this statement? What do we think could have gone wrong with this statement? Some time to think. What could go wrong with this statement? What's happened here is that instead of counting the parts that is shaded, we've counted that the parts are not shaded. So this picture represents 1/5 of the shape, which has been shaded. 4/5, so 1, 2, 3, 4 parts haven't been shaded. So 1/5 has been shaded. Now we're going to have a quick look at non-unit fractions. So a unit fraction is when our numerator is always the number 1. Always the number 1. So we did look at some non-unit fractions yesterday. So this should be fairly straightforward for us. Looking at this shape here, this circle. How many parts are shaded? How many parts are shaded? How many parts are shaded? Counting together. 1, 2. 2 parts are shaded. How many equal parts are there all together? 1, 2, 3. There are 3 equal parts. Going back to what we've already looked at, which is that the denominator shows us the total number of equal parts and the numerator shows the total number of parts that we have, or in this case, are shaded. What do you think our non-unit fraction is for this diagram? There are 3 equal parts. Our 3 equal parts are our denominator. 1, 2, 3. The parts that we have, or the parts that are shaded, 1, 2. Our shape here is 2/3 shaded. 2/3 of this circle are shaded. 2 parts out of 3 have been shaded. Have a little look at this bottom one and see if you can fill them out yourself. Maybe just saying them to an adult or writing them down on a piece of paper. How many parts are shaded? How many equal parts are there all together? I'm going to give you 30 seconds to complete this. If you're not sure, you can rewind and look at the definitions of the different parts of fractions to help you out. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, eyes on the video. Right, how many parts are shaded all together? Count with me. 1, 2, 3. 3 parts. That's a horrible looking number, 3. Trying to do this, I don't have my magic pen. 3 parts are shaded. How many equal parts are there all together? 1, 2, 3, 4, 5, 6. There are 6 equal parts all together. Now we need to write our fraction, our non-unit fraction. There are 6 equal parts all together, which make up our whole. I know that my denominator shows me and tells me how many equal parts are there all together. So I'm going to write my number 6 there. And I know that my numerator tells me how many parts we have, or in this case, how many parts are shaded. So I'm going to write my numerator up here. We could also look at these, not just with shaded parts, but we can go back and look at our cubes. So all together here, how many cubes do I have? Counting with me. 1, 2, 3, 4, 5, 6, 7. I have 7 cubes. So 7 equal parts. I now want to find out how many of my equal parts are coloured red. How many are coloured red? 1, 2, 3, 4. 4 red cubes. And when I'm here saying, let's just make that a bit easier so you can see that. When I'm saying equal parts, I'm meaning how many cubes. So there are 4 red cubes and I have 7 equal parts. What do you think my denominator is going to be? What do you think the denominator is going to be? The denominator means, remember, how many equal parts you have all together in total to make up the whole. And in this case, it is 7. Now, our numerator, remember, is how many parts we have, or that we are looking to find. So in this case, we're looking to know how many out of 7, how many cubes out of 7 are red. Let's count together. 1, 2, 3, 4. We know it here. 4 red cubes out of 7 are 4 cubes out of 7 are red. 4/7. We don't 4/7. It's a bit of a tricky one to say, sevenths. 4/7. 4 cubes out of all the 7 cubes are red. Bit of reasoning here. The shapes below represent 3/6. Do they or do they not? Which one is the odd one out? Which one shouldn't be here at all? Have a pause of the video now to have a look at this question and come up with a great sentence, full sentence, to tell your adult or anyone who is in the house why one is the odd one out. Okay. The shapes below represent 3/6. How can we check that and find out which one is the odd one out? What is the easiest number for us to check first? We could check and see what each shape has in their numerator. That would work. Or we could check in denominator. Let's check and see our denominator. So how many equal parts there are altogether? 1, 2, 3, 4, 5, 6. So I know here that I have 6 equal parts. Let's count here. 1, 2, 3, 4, 5. Okay, 5 equal parts. And finally this shape, 1, 2, 3, 4, 5, 6. 6 equal parts. This is already starting to show. Let's see how many parts are shaded. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So in each case, 3 of the parts are shaded, or of the parts that we have. So each fraction has 3 as their numerator. However, the middle fraction is only divided, the middle shape is only divided into 5 equal parts. The others are divided into 6 equal parts. So our odd one out is 2 because it is divided into 5 equal parts, not 6 equal parts. Therefore, it doesn't represent 3/6, it represents 3/5. So it is now time for you to go on to your independent task. You here have to write the fractions which are shown in all the pictures. So you can just write out the letter of the picture and write the fraction next door. You can then also draw, for your next part is to draw images to represent the following fractions. Remember, when you're writing a fraction, the denominator is the number of total equal parts altogether in a fraction. So how many parts it's divided into. So remember, we had with our cubes, we had with our kiwi fruit and our pictures of our shapes, we need to count the number of equal parts first. Then you need to look at the number of shapes shaded in this case. So you need to look, and for example, seeing with this one as an example, how many equal parts are there? 1, 2, 3, 4. 4 is going to be our denominator. And our numerator, so the number of parts we have, or in this case, the number of parts which are shaded, is going to be 1. 1 part out of 4, 1 part out of the 4 parts in the shape is shaded. 1/4 of the shape is shaded. If you have finished, there is a math challenge attached as well. Don't forget your daily brain busters for your arithmetic, and looking forward to seeing some fantastic work on Seesaw. I will see you again tomorrow for your maths lesson. Have a great rest of the day.